This is a brief demo of one of the utilities available in the interpmont extension for EEGLAB, specifically how to interpolate your montage that's currently loaded in the dataset to a set of sites in a standard coordinate file. So I'm just going to load dataset here, and this dataset has 59 channels, and we'll see that 7 of the channels are missing. We'll plot them by name, and we can see that these are standard 1020 names with a few sites missing. Now if we plot the scalp data, and we can see the layout of some of the activation. Just plot a topography at this blink, and then we can see here that blink frontal positivity. Now what we'd like to be able to do is actually replace this montage of channels with a set of locations from a coordinate file. Now this will work with any coordinate file. I've chosen one that is actually a different orientation of the currently loaded data, but has 1020 names, and any of the recognized coordinate files for EEGLAB will work. In this case it's a ELC file with a standard format. So what we'll do is we'll go to EEGLAB and Tools, Interpolate to Coordinate File, interpolate the data to sites in a coordinate file. I pick a coordinate file, so here's one we were just looking at, the standard 1020, account 19 elec, and then I'm going to add this option called manual and turn it on. What this will allow us to do is the co-registration window will come up, which will allow us to warp the current chanlock structure to fit the surface of the location file that we're opening. And that way the data that we interpolate to will actually match the appropriate surface. Okay. And the co-registration window comes up. In this case you can see it's particularly important if we were just to interpolate to the sites. The green sites are the ones that are currently loaded and have data. The dark brown beige sites are the ones that are in the location file that we want to interpolate to. So I'm just going to turn some labels on so we can see them. In this case both coordinate systems have the same names, which will make it easier to rotate and everything, but doesn't end up confusing it internally. So I'm going to make this seem a bit easier than it is. So I've rotated these a couple times. It's actually a negative. Okay, so I'll rotate this so the two montages sit right on top of each other. So what we're going to do now is we're going to take all the data that are located at the sites in the green locations, and we're going to put new channels on the head everywhere where these brown sites are, and then using the data that's in the green locations, we're going to interpolate to the brown ones, and then the brown ones are the only channels that are going to be left after the sequence is done. So I'll hit OK, and this is a long continuous data set. This will take a couple seconds to interpolate. And then what we'll do is we'll plot the new topography, just getting the channel labels, and then we'll replot looking at the activation of an eye blink. Okay, and that's done. Now we see there's only 19 channels left in the data. So what I'm going to do is I'm going to plot the channels by name. So here we see the new head, but the frontal sites are now looking to the left. And if we plot scroll data, and I'll plot a topography at the blink, we see that it looks like this. So even though we've used a coordinate file that was rotated, we see that the data also get rotated, in that the frontal sites have the frontal activation. Now to correct this, all that we have to do is tell EEGLAB that the nose direction got rotated, so we'll say the nose direction is y plus, and then do a check set. Now if we plot the data, we get the appropriate topography. As well, if we then plot the name, we get these. And that's basically the sequence for going from a montage that you currently have in your data to warping it to any surface that you have in a coordinate file and then rotating it back in the right direction.